So the warm-up question for today says 2 balls fall from the 4th floor railing to the floor of the atrium below. One ball is dropped from rest and the other is thrown downward. Which has a greater air time and which has greater acceleration? So what do you think? Which one do you think would take longer to reach the ground? Being dropped from rest or being thrown downward? Dropped from rest, right? I mean, just logically speaking, that would make sense. That if you dropped it, it would take longer to reach the ground than if you threw it downward. And that is the answer to the first question, which has greater air time. The greater air time is going to be the one that is dropped because it doesn't have an initial velocity. That initial velocity being downward is going to cause that other one to reach the ground sooner. Okay, so that's your first answer. The second one says, which has greater acceleration? Guys, what causes these 2 different balls to accelerate toward the ground? Gravity. Is gravity going to be affected by whether I drop something or throw something? Or is gravity just gravity? Just gravity. Okay, and so the acceleration should be the same. Okay, the acceleration acting on both of these objects should be negative 9.8 meters per second every second, because that is the rate at which all objects accelerate due to gravity. Okay, toward the ground, 9.8 meters per second every second. Whether it's thrown down, whether it's dropped, whether it's thrown upward, whether it's thrown forward, it doesn't matter. All objects are going to accelerate toward the ground at that same rate. And so that acceleration is not going to be affected by the velocity with which I throw or drop something. Okay, and that was covered in the notes from yesterday, which if you haven't taken a look at them, you guys do have access to all of the notes. So, and there was the video, although you mentioned that it cut out partway through. So you can still click through it. All the animations are in there. That's just from yesterday. We're going to go over a couple more examples today, though, because I just want to make sure that you guys are comfortable with it going into the assignment 202.2, because it does have some of those free fall type questions in it, but then also to help you with your work assignments in the future on free fall, your quiz, your test, all of that stuff that you have coming up. Okay. Your acceleration RA, which you worked on a couple days ago, is due on Friday, and we will have some amount of time in class, but hopefully you've already finished the vast majority of this. So we'll take a look at that in a little bit as well. So I said I wanted to go over just another practice problem. So if you'd like to copy this one down just to have a free fall problem to look back at, this would be maybe a helpful one to have. It says, Sarah drops a rock from a bridge into the water below. After releasing it, she hears the splash as it hits the water 2.7 seconds later. Assuming no air resistance, how high is the bridge? And so I went ahead and drew a diagram of a rock going downward, taking 2.7 seconds, and that's all the information I really have that I could add to my diagram. But when we go through the problem-solving process, it's the same process that it was when we did our other acceleration calculations, because things that are falling are accelerating in the same way that things that are accelerating along the ground, it's just when they're falling, their acceleration is due to gravity as opposed to a car accelerating being due to its motor. Okay, but given information, that's where we're going to start with all of these calculations. And there's only one number in the question that I'm given, and that is a time of 2.7 seconds. Okay, so that's the only number that's told to me in the question. However, that's not the only information I know to be true. What else do I know to be true in this scenario? Yes? Yeah, I know that. I know that every single time. If you have an object falling, I know the acceleration every single time to be negative 9.8 meters per second squared. There's one other thing that I know, though. Anybody tell me what else I know about this rock? Was it thrown? No. It was dropped, which implies that it has an initial velocity of 0. Okay? It doesn't say it in the question. Sometimes it'll say dropped from rest. Okay, and that's more clear. But if it says it was dropped, you're going to assume that your initial velocity is 0. If it says thrown, obviously that's not the case, but in this case it was dropped. So my initial velocity is 0, and as we mentioned a second ago, our acceleration is due to gravity, and it's negative 9.8 meters per second squared. Okay, so these questions might be a little bit trickier only because they don't appear to give you enough information sometimes, but it's there. Okay, if you have an object that is dropped, it's an initial velocity of 0. And it's not going to tell you acceleration due to gravity because it expects you to know that falling objects fall at that rate. Okay, so it's not going to be listed in the question like they were in the problems earlier this week. All right, my unknown, what I'm looking for, the U in guess. I'm looking for how high is the bridge. I want to know what my displacement is so that I can determine my height. Okay, and so from that, we're going to look at our equations. I've got 4 of them, and I know time, VI, A, and I'm looking for delta X. So take a look at those 4 equations real quick, A, B, C, and D. Which one do you think would be, well, which one is the only one I can use to find this in one step? C. Okay, now, yes, it is possible to do it another way and take 2 steps, but C is the only equation that I have that I can use to solve this problem in a single step. Delta X equals VI times T plus 1/2 times A times T squared. Okay, so that's right here now, right? There's my equation. My next step is to substitute into that equation. So I have VI is 0, T is 2.7, plus 1/2 times A, that's negative 9.8, times 2.7 squared. And now we're going to solve and just do the math. Okay, that's going to be 0 plus, because 0 times anything is 0. And then half of negative 9.8 times 2.7 squared is negative 35.721, and therefore my displacement is negative 35.721 meters. Now, the question wasn't what is the displacement of the rock, it was how high is the bridge. And when I report this as a height, I'm just going to say, well, that means it was 35.72 meters tall. Okay, because it fell by that distance. And the reason this has a negative in front of it is because it went down. So its displacement is negative, but the height of the bridge would just be the absolute value of that number. You could include the 1 if you want, 35.721 or 35.72 meters. Are there any questions about that calculation? No? All right, let's do a follow-up then. Okay, same scenario. What is the impact speed of the rock? Okay, same scenario, we're just asking a different question. How fast is it moving when it hits? What's its final velocity? Okay, so we still have the same information given to us. I went ahead and included delta X because I already found it, may as well include it, I could use it. Okay, and this time my unknown that I'm looking for is VF. I want to know how fast it's moving when it strikes the water. Again, I'll turn to my equations, and I can solve for VF with equation A, B, or D. And I actually could use any of them because now I know all of the other variables. I know T, VI, A, and delta X. So I could use A, B, or D because all of those have VF in them and I know everything else about the scenario. However, I'm not going to use all of them. I'm going to use the easiest one, which is A. Okay, now could you do a different one? Sure. Nothing wrong with it, but like D, for example, is much more difficult to rearrange, so I probably wouldn't choose that. A or B would be the easier way to go. Okay, so my final velocity is equal to my initial velocity plus acceleration times time. That is my equation. I'm going to substitute into that, and I have VF equals 0 plus negative 9.8 times 2.7, which gives me 0 plus negative 26.46, which is my final velocity, negative 26.46. It is negative because it is downward. Okay, so again, this is the type of questions that you were looking at yesterday, and you will have some of these in this assignment that you're working on today as well. Here's a little follow-up question though. How would my final velocity change if the rock was thrown downward? Would it be faster, slower, the same when it hits the water if it was thrown? What do y'all think? Okay, well, I'm just looking at it mathematically. Okay, if you threw a rock downward and it still took the same amount of time, it'd have to be off a different bridge. Mathematically speaking, this wouldn't be a 0, so you'd be at a faster rate of speed if you threw it downward, because you'd be adding on that initial negative velocity to the one that we just calculated. Okay, so again, your final velocity would be faster if you threw something downward, assuming it had the same air time. Okay, which would mean you'd have to be off of a different structure. But if it didn't, then you'd have to recalculate it and see. So anyway, just something to think about, because we will start introducing problems like that as well, where you have objects that have an initial velocity and not just being dropped from rest. Okay guys, so that's going to hopefully help recap some of the math from yesterday. And so I'm going to ask you to go ahead and reopen the assignment 202.2 acceleration analysis problem set in Schoology. You started it earlier this week. And this particular tab should be finished by tonight. So again, you're not submitting anything yet, but go ahead and work on it. And if you have questions as you're working, please let me know. If you are already finished with this, then I would suggest that you work on your RA and use the time for that instead, if that is something that you still need to work on as well. But if you guys have questions, please let me know.